everyone. Welcome back once again. This is the academia series. We are still on the topic elements, compound, and mixtures. But today, specifically, we're going to look at formation of ions and formation of compounds, binary compounds specific. Please subscribe to my channel so that you don't miss any post from me. At the end of the lesson, I expect learners to 1. Describe the formation of ions and also write some formula for some binary compounds, simple binary compounds. Now, once again, let me introduce you to the periodic table. For you to master the writing of ions, being it cations or anions, you have to master the periodic table. Let's look at some interesting facts about the periodic table. Now we have columns, that is from top down. We have columns, and then we have rows. Let me take it that one. From the left hand side to the right hand side, we call that the rows. So row number 1, row number 2, number 3, number 4. And then we have columns as well, 8 columns here. The columns are given the name group. Whenever you see it, it means group. So we have group 1 up to 8. Then the rows are named as periods. So we have P1, period 2, period 3, period 4. Alright. Then I've told you that this is the mass number, atomic number. Please do not forget, do not worry yourself memorizing the atomic numbers. They are constants. If you need them in a question, they provide it. But you must know the atomic numbers so that it will help you to know which one comes after what. Because if you know that hydrogen is 1, then helium is 2. Know that hydrogen will come before helium. Another example, if oxygen is 8, fluorine is 9, know that oxygen will come 8 before 9. Okay. Then let us look at the periodic table once again. In the formation of ions, let's check something here. Before even I come to that, why do we have hydrogen, lithium, sodium all in 1? As we saw just a minute ago. Why are they all put in 1? This is because we realize that their last shell contains 1 electron. Look at them. That's what I've underlined with the green marking. This one, their last shell contains 2. So they are in group 2. 3, 4 in the last shell, 4 in that order. 7. So they are in 7. Those in period 2, why do we put this hydrogen and helium in period 1? It is because they have only 1 shell. Having 1 electron, you draw only 1 shell for it. 2 electrons, only 1 shell, 1, 2. Here, the first shell stays 2, so the next electron will go to the next shell. So these ones have 2 shells, 1 KL, or shell 1 or shell 2. That's why they are in period 2. These have 3 shells, KLM. That's why they are in period 3. All those here have 3 shells. Those here have period 4 shells, KLM, KLMN. 4 shells. That's why they are in period 4. Alright. Now, let us quickly look at this. I have separated the noble gases from the other 17 elements. Why? Because the noble gases are unique. We call them noble gases. Sometimes you can also call them the unreactive gas. Unreactive gas means it will never react, or it will never combine with any of the elements, or inert gases. Let me give you some more interesting facts about them. They are the only gases that exist in the atomic state. Therefore, we have helium gas, neon gas, argon gas. Their smallest unit is atoms. But all other gases you know, they exist in molecules. Oxygen, carbon, whatever they all exist as molecules. Why all these special properties about these noble gases? This is due to the fact that we are saying that the first shell must be 2. Helium has only 2, so naturally it has fully filled shell. We are saying that the second shell should be 8. Neon has 8, so naturally it has the 8 shells, 8 electrons in the glass shell. Argon also have 8 electrons in its large shell. So naturally, they are fully filled, and therefore they are very stable. If I say an element is stable, it means they can exist in that form. All the other 17 I have here are not stable because they don't have fully filled electrons in their large shell. Let's take lithium. Lithium, the second shell is supposed to take 8, but lithium has only 1. If you take a look at phosphorus, the third shell is supposed to take 8, but it has 5. So, in order for them to become like this, some of them has to lose electrons, some has to gain electrons. So, for instance, lithium will have to lose 1 to become like helium. Aluminium has to lose 3 to become like neon. Phosphorus has to gain 3 to become like argon. So in the nutshell, let's look at something here. We have those over here. If you look at what I have drawn, those over here all will lose electrons, and those over here all will gain electrons. Let me come here and illustrate that carefully. So we have those which have to lose electrons and those which have to gain electrons for now. Okay. Let me continue for now. We shall revisit it. So all those here, all those over here will have to lose electrons. All those on my right hand side here on this line border, they have to gain electrons. Okay. Now let's look at this. If they lose electrons, what happens? We are going to look at the formation of ions. We know that sodium has 11 protons and then 11 negative electrons. Protons, I have told you, they are positive, electrons are negative. So when we add them together, we get what? 0, a net charge of 0. And we can write this as sodium atom with no charge because the charge is 0. We write the EC as 281. Let's come here. Sodium still has 11 protons, but because it wants to become stable, it has lost 1. So now electrons are now 10. Let's combine them together. What's the difference? Plus 1. That plus 1 is what we write right here. Sodium has now become an ion, and because it has lost 1 electron, compared to this, we have EC 28. And because it is positively charged ion, I think I've told you already, positively charged ion is called a cation. So sodium is a cation. Alright. Let's look at chlorine. You realize that chlorine also has 17 protons and then 17 negative electrons. So once again, on this side, if I add, I'll get 0. I'll get a chlorine atom with EC of 287, no charge, because the charge found is 0. Now, when I come here, I have 17 protons. Because it wants to become stable, it has gained 1 electron. So when we compare the number of electrons with the number of protons, electrons are now more. The difference is -1. -1 for the electrons, so extra electron. So we indicate that here. So now chlorine has become a chlorine ion. We no longer call it an atom, it's an ion. Compared with this, because it has gained 1 electron, the EC is 288. And because it is a negatively charged ion, we shall call it an ion. An ion. So let me also say that when the atom has not gained or lose electrons, we say it is electrically neutral. It is not charged. It's neutral because the charge on it is 0. The positive and negative cancel. So in the BEC years, I will be asked, explain why the atom is described as being electrically neutral. You have to say that the number of positive protons equals the number of negative electrons, and they cancel out, leaving the atom a net charge of 0. Therefore, it has become electrically neutral. When it gains, because the electrons have become more than the protons, it is no longer electrically neutral. This one is positively charged. In the case of sodium, we saw that it has become positively charged. So now, in an attempt to become stable, let's look at this. All those here, you see, you have to lose. When you lose, you become positively charged. When you lose, you become positively charged. So this one tells us the boron has lost 3 electrons, as I indicated to you earlier. Aluminium has to lose 3 electrons to become stable. Magnesium has to lose 2. Phosphorus has to gain 3. Oxygen has to gain 2. Chlorine has to gain 1. So when you gain, you become negatively charged. When you lose, you become positively charged. Because I've shown you just not long ago that when you lose, the electrons will decrease in number, but the protons will decrease. The protons will become more than the electrons by whatever number you have lost. So that magnesium before, it was 12 protons, 12 electrons. But when you lose that 2 electrons, the protons have become more than the electrons by 2. That's what the charge is. So when you see a charged compound, you should be able to understand this. It has lost 2 electrons, and that the protons are now more than the electrons by 2 in the case of magnesium. Carbon and silicon are in the middle. We may sometimes lose plus 4 electrons or gain 4 electrons. So that's why we have plus or minus 4. Alright. Now, let us look at binary compounds. What are they? They are compounds that contains 2 different elements only. For example, sodium chloride contains sodium element, chlorine element. So I can call it a binary compound. Ammonia, nitrogen, and hydrogen. So it's also a binary compound. How are they put together? For now, I just want to show you this, but that's not my point of interest now. We will take maybe bonding later. But how are they put together? When sodium becomes positively charged and chlorine becomes negatively charged, there's an attraction between positive and negative, and they come together to form this. This kind of bonding is called ionic bond, formed between positively charged ion and negatively charged ion. In other words, cations and anions. Let's come to nitrogen and then hydrogen. Here, they share electrons. This is how they share. Nitrogen will bring 1, hydrogen will bring 1, then they share. So these 2 here, nitrogen can say it is for me. Hydrogen can say it is also for me. So this is how the sharing goes on. I just want to show you this and inform this. This kind of bonding is called covalent bonding. Covalent bonding. So now, let's go ahead and form some binary compounds. There is a simple technique to help you write the correct formulas for binary compounds. Now, I'm giving you all the charges for the first 20 elements. There are some elements that I will bring to you later. They are not among the first 20, but you must know them. I will give their charges as well. For example, iron. So for sodium, we have charge of 1. Here to charge of 1. So here that is the 1 and 1. Here, 1 and 1 can cancel. So they go away, and I can just write the formula as sodium chloride, which is correct. Why? Because 1 and 1 can cancel each other. That is, positive can cancel the negative. That's why you write the formula without any number in the way. So this is the correct formula for sodium chloride. When it comes to calcium, calcium is 2+. You can refer to the table with the charges. So that is the 2 for calcium. Chlorine is 1, 1. So 1 cannot cancel 2. When it cannot cancel, exchange the numbers. And when you exchange the 1 is now found under calcium. The 2 is now found under chlorine. So what happens? Calcium 1, which we don't write, chlorine 2. So this is the correct formula for calcium chloride. Magnesium, 2 here, 2 there. 2 and 2 can cancel. So once again, we don't write any number. When you look at hydrogen, 2 here, 1 there. 1 for hydrogen, 2 for sulfur. You can't cancel. Let's cross them. After crossing them together, 2 for hydrogen, so 2, 1 for sulfur. So in that order here,